Hello everyone and welcome back to another minute concept on calculus, this time about integrals. So now that we've moved on from differentiation, integrals are another topic that we need to talk about. So whereas derivatives were the rate of change, integrals are the area under a curve. Now, this area underneath a curve could mean many different things. So it really depends on the topic. However, for example, this is just an illustration. An integral would look like this shaded area here. In sciences such as physics, there are values that can be derived. For example, the derivative of displacement is velocity, while the second derivative of displacement is effectively the derivative of velocity is acceleration. Now, if I want to undo that and I want to go backwards, all I have to do is integrate acceleration, and that will get me velocity. And I integrate velocity, and that will get me displacement. And that is how integration works in sciences such as physics. So, integrals follow a similar rule, or like one of the most basic rules of integrals is like the most basic rule of derivatives, which is the power rule. So, allow me to get rid of this real quick. When we have integrals, we only have to focus really on whether or not we can solve it by parts, substitution, or as a whole. And as a whole means applying, for example, the different integral counterparts. Like for example, in derivatives, when the derivative of sine is cosine, and in integrals there are also counterparts. Now, for this intro to integrals, I'm just going to talk about the inverse power rule. So whereas the derivative is, let's say, x to the power of n is equal to n times x to the power of n minus 1, this is quite literally the inverse. And what does that mean? Basically, the inverse is going to be described as, hold on, let me just get rid of this here. The inverse is going to be, instead of multiplication, it's division, and instead of subtraction, it's addition. So the integral of, okay, hold on, let me get this. The integral of, let's say, x, any number x, is equal to x to the power of n plus 1 over n plus 1. So, for example, let's take the integral of, let me shrink this. So, let's make the integral of x cubed. The integral of this would be equal to x to the power of 3 plus 1 over 3 plus 1. And this is basically x to the power of 4 over 4. And in integration, there's always going to be a constant plus c. And okay, the reason why we have this constant is because if you recall, in derivatives, the derivative of a constant is equal to 0. That said, in our integration here, we could have had any constant at all, and it would have been the equivalent of the original derivative. So we're essentially compensating for the infinite amount of numbers that could be our constant by placing c, which is also known as the constant of integration. And that essentially is the overall, let's say, overview of integrals in calculus. So there's going to be more in-depth videos on this. However, this might take a while as personal schedules are conflicting. However, I hope for this video, just the basic rule of the anti-power rule, I hope that that makes sense. And I hope that you guys learned something from this, so that on the next videos, once my schedules align again, I can teach you guys about integrals. So thank you everyone, and I'll see you in the next video, and I hope you guys learned something. So if you guys like the video, please like it, and you guys want to subscribe, feel free to do so. Thank you everyone, and goodbye.